Welcome back to this video series on the topic of fervent factorization. Chapter E, non-monic trinomials. In this lesson, you'll learn how to factorize non-monic trinomial expressions using the sum and product method. A non-monic trinomial expression is an expression where the coefficient in front of the second order term is non-unity. In other words, it's neither 1 nor -1. In this instance here, we see there's an a. This a represents a number that's neither 1 or -1. And by definition, it cannot equal 0 either, otherwise it wouldn't be a trinomial. What we're going to do is look at how we can factorize these using the sum and product method. Example 1, factorize the following expression. We have 3x squared plus 29x plus 40. What we're going to do is we are going to factorize this non-monic expression using the sum and product method. Now this is very similar to what we've already learned, where the first step we need to do is we need to split the linear term into two smaller terms. We'll call it ax and bx. After which our job is to determine what two values of a and b will sum to give a value of 29. Now where this method changes with a non-monic expression is when we're calculating a and b, the product of these two numbers is no longer going to be equal to the constant, in this case 40, but rather it's going to be equal to the constant multiplied by the coefficient of the second order expression. In this case, a and b must multiply to equal 40 times 3. So in this instance, our product target will be 3 by 40, which is 120. Our summing target remains the same, of course, of 29. Now next step, what I'm going to do is I'm going to pick out these numbers that sum to equal 29, but multiply to equal 120. So I'll start off with 29 over here. I'll split that into 1 by 28. And that will give me 28. So the sum of these two still equals 29, but the product is 28. Now what we're going to do is, because we can see that this is quite a fair way off, we'll ramp it up a bit. So we'll go 4 by 25, which will give us 100. And then we'll go 5 by 24, which is what we're after, 120. So therefore, because we can see that we've found our product target, we know that our two numbers for a and b are 5 and 24. Putting these in, and now we're ready to start the factorization process. Looking at the first bracket, we can see that there are no common factors between 3 and 5 because they're both prime. However, what we do have in common is a single x. So we'll factorize for that. Next, we have something that looks a little bit unkind. We have 24 and 40. Now these are not directly divisible by one another, but they will have factors that are in common. Now what we can do to make this a little bit easier is we can look at the bracket we've already done, and we've got a 3 and a 5 left over. Now you ask the question, what happens if I divide 24 by 3? And what we find is that we are going to get 8 left over. Similarly, what happens if we divide 40 by 5? Well, again, we get 8. So that means that we're going to pull out a common factor of 8, which will leave behind 3x plus 5. And instantly what you can see is that we have two factors that are common, and then we have what's not common. Because of that, we can factorize across, so we can say x plus 8, and then we can have 3x plus 5. And of course, when we're doing this, the order doesn't matter, so we can have it this way or we can have it this way around. And that's as far as we're going to take this one just for now. We will come back to this one in a sec, but our objective was to put this in its factorized form, and we have achieved this. Next example, 3x squared plus 29x plus 18. What we need to do is we need to factorize this such that we split our middle term to ax plus bx. Next, we need to find the combination of A and B such that they sum to 29, but they multiply it to 3 by 18, in this case 54. So our summing target is going to be 29 yet again. So I'll split this into 1 plus 28, and then I'll change it to multiplication. Next, I'll start ramping this up by 1, down by 1. This will give us 54 nice and quick. So our values for A and B are going to be 2 and 27, or we can change it the other way around if we choose, it doesn't matter. Therefore, we have this expression as shown over here, although I will change it to go here and here. Okay, next step, we have our implied brackets, and we want to factorize across these implied brackets. Looking at the first one, once again we've got a 3 and a 2, they're both prime, and therefore we can't factorize out a common number, so we'll just take the x for now. 3x plus 2 plus, looking at these numbers here, again they're not the nicest to work with, they're not totally divisible by one another, but we do have a bit of foresight in knowing that we're expecting a bracket to look like 3x plus 2. So if we divide 27 by 3, we get 9, and if we divide 18 by 2, we also get 9. So the common factor here is going to be 9, and left over is 3x plus 2. Observing, we have a common factor of 3x plus 2, and we leave behind x plus 9. Therefore, 3x plus 2, x plus 9. And this is in a factorized form, as we can see. However, we are able to go one step deeper with this. Although this is a factorized form, it's not the most factorized we can be in. If we observe, we have a number in front of this variable here. Our x has a coefficient that's non-1. As mathematicians, we really like having coefficients of 1 when we're dealing with brackets like this. So what we're going to do is we're going to factorize out this 3. The way in which we can do this is we can say factor of 3 here, and then we can pull a factor of 3 out of the 2. In this instance, we'll just say that this is y for now, and the second bracket remains unchanged. Now the question is, what happens when you factorize 3 out of a 2? Well, you end up getting a fraction, so we get the 2 over here, and it gets divided by the 3. So if you multiply 2 over 3 by 3, the 3's cancel, and if you have a 2 and you want to factorize out the 3, you simply put it over 3. And because of that, we have a common factor of 3, which we are allowed to factorize out. So therefore, we end up pulling out 3, we leave behind an x plus 2 over 3, and x plus 9. And that makes it easier when you're finding zeros in the future. So this over here is our most factorized form. It's not to say that the previous form was not factorized or not correct, it's just not the most factorized form. So just like that. And if we can do it on this example here, then we can do it back up here, where again, we're going to pull out that 3. Jumping straight to it, we pull out the 3, we leave behind an x. We had a 5, but we pulled a 3 out of it, so it becomes 5 over 3. And then x plus. Easy does it. And therefore we arrive at our most factorized form. You don't have to do this step if you really don't want to. You are able to leave it in this one. Okay, let's look at some trickier stuff. Factorizing non-monic trinomials containing negative terms. What we're going to do here is we're going to factorize these expressions where the difference with these ones is that they now have negatives involved. The process is still the same. Doing this, we're going to do the split, and now we need to start finding our targets. Product target is 3 by 63. In this instance, that's going to be 189. The summing target is still negative 34. Okay, now looking at this, what you can see is that our product target is positive, but our summing target is negative. What this is suggestive of is that both numbers A and B must be negative because the multiplication of two negatives is a positive, but the sum is a negative. So in saying that, what we find is we're going to split minus 34 into, let's say, minus 1 plus minus 33. Next, we'll change it to a times, and that will give us plus 33. Going up by 1, we'll go minus 2 times minus 32. In this instance, it will be 64. So the growth is slow, so let's ramp it up a little. We will go to minus 6 times minus 28. This will yield 168. We're getting there. We'll go minus 7 times minus 27, and that will give us 189, which is our product target. Therefore, values for A and B are going to be minus 7 and minus 27. Taking care of this, we're going to go, common factor is x, therefore we get the bracket 3x minus 7. Next, we're going to take out a common factor of, we have 27, we want to turn it into a 3. If we divide 27 by 3, we get 9 left over, so this will give us 9 over here. And if we divide 63 by 7, we're going to get 9 as well, so this is going to be like so. Now what you can see is that we don't have matching brackets here. This one is plus 3x minus 7, this one's minus 3x plus 7. What this means is we need to factorize out the negative, so I just flip the symbols and change it to negatives, and therefore we get matchy-matchy. Writing this out, and then this is our factorized form. However, we can of course go one step further if we choose to. We simply factor out the 3. That becomes 7 over 3. X take 9. And there's our most factorized form. We are dealing with 5x squared minus 21x minus 20. We are looking at a product target of 5 by minus 20, which is going to give us, this will be negative 100. Next, we're looking at our summing target, which is minus 21. Now, if we have a look, our product target is negative, our summing target is also negative. This is indicative that one number is positive, one number is negative. Secondly, because you can see that this is a negative summing target, it means that the larger of the two numbers is the negative one. So that implies that we're going to go something like, let's go, minus 21 can be split into 1 plus minus 22, and that will give us negative 22. So that's quite far off the mark. So let's ramp it up a little. Let's go for, we'll go 4 times, this will be minus 25, and that's going to give us the 100. So with a little bit of practice, you'll get quicker at doing this, just like this one was. A and B are 4 and minus 25, so we'll split. We'll go 5x squared. We'll put the minus 25 here this time. So we get 5x squared minus 25x plus 4x minus 20. We do our implied brackets again. Take out the 5, take out the x, leave behind an x, and leave behind the minus 5. Plus, take out a 4, leave behind an x, and leave behind the minus 5. So therefore, what you can see is that we are going to have 5x, going for the final bit of factorization. Pull out the 5, leave behind the x. We have 4 over 5 because we took 5 away from it. Factor of 5 out, I should say. And then x minus 5. So that and that will be our factorized forms. So in summary, to factorize non-monic trinomial expressions, we use the sum and product method in these instances to split the middle term and then we pick the coefficients of the middle terms to be the product of the constant and the coefficient of the second order term, and that must sum to equal the coefficient of the linear term. We then plug those values back in and factorize. Okay, now we do have instances where we get some slightly trickier cases. Example 3, special cases. Factorize the following expressions and state the zeros. In this instance here, we're dealing with a case that doesn't necessarily look like it's a trinomial because it is to the power of a 3. However, with a quick common factor factorization, we can turn this back into a trinomial expression. So what we can do is we can factorize for the x. And all of a sudden inside the brackets we can see that we now have a trinomial expression. Next I can see that looking at this we have a common factor of 2, so I'll go ahead and take that out as well. And this makes the numbers that we're working with in this question a little bit easier. Now next step is we want to factorize this. We've already got what's outside, that's fine, we can just ignore that, but what we'll do is we'll factorize in the brackets here. Now we have a trinomial expression and it looks like we'll be able to factorize this using the sum and product method. So picking out my product target, it's going to be 3 by 12, which is 36. And the summing target is going to be minus 20. Now we can see that this is negative and the product target's positive. So that infers that the coefficients of the number we split will both be negative. So because of that, the first number will be minus 1 and the second number will be minus 19. And if I change this to times, then it's going to be 19. Stepping this up, I'm trying to hit 36, so I'll go minus 2 times minus 18, and that will give us what we're looking for, 36. So we'll split the middle term now. Next, we will factorize across these implied brackets. We're going to have 2x here. First one, 3 and 2 are prime, so we can't factorize, so we'll just pull out the x. Leave behind 3x, take 2. Next, we have 18 and 12. Notice that this negative kind of belongs to in here, so what we'll do is we'll rewrite this, call that plus, and then we'll factorize. We want to get 3x minus 2 inside the brackets. First term is negative, so we'll divide it by a negative, so we'll pull out a negative. We want to deal with this term over here. We ask ourselves what happens if we divide 18 by 3, and we're going to find that we get a 6. So what we're going to do is we're going to pull out a common factor of 6. This will leave us behind 3x. Notice it becomes positive, and if we take out negative 6 from 12, we're going to be left with minus 2. So there's our factorization. Looking at what's common, these two are common. These are uncommon. 2x, 3x minus 2. And then we're going to have x. So there's our factorization. Okay, next we're going to look for the, actually we won't look for the zeros yet. What we'll do is we'll go for one further step of factorization. We'll put the coefficient in front of here as a 1. In doing that we pull out a 3. So we'll go 6x. So we've taken out the 3, we leave behind x, take 2 over 3. Then x, take 6. Next we'll look for our zeros. We ask ourselves what values of x will make this expression equal 0. And the first one you can see is, well, if you sub in 0 here for x, then the whole thing will become 0 because anything multiplied by 0 is 0. So first 0 is at x equals 0. Second 0 is going to be at, how do we cancel out a minus 2 over 3? Well, we give it 2 over 3. So next 0 is at 2 over 3. And final 0 is going to be at, that's minus 6. Give it a 6 and you'll get 0. So there's our zeros. So in summary, to factorize this particular example, we pull out the common factor of 2x to turn this into a trinomial expression inside the brackets. And from there, we can factorize this trinomial expression down using the sum and product method, after which we get the zeros because that's what the question wanted. Alright, next case. We have minus 3x to the power of 4 plus 12x to the power of 3 minus 12x squared. We want to factorize this. Now, much like in the previous example, we can see that we have powers that are higher than the square. However, this is seen across all of the terms, so we're able to factorize out these x squared terms to begin with. Next, we can turn our attention to the coefficients. If you observe, all of these coefficients have a common factor of 3. So you've got 3, 12, and 12, all divisible by 3. And finally, the second order expression has a negative in front. We can factorize that out as well because it will make our life easier later. So we'll factorize out 3 minus 3x squared. This will give us minus 3x squared times by, in brackets, x squared minus 4x plus 4. Now, next thing you're going to see is that we've got an expression that looks special. Inside here we have the trinomial expression where it is a perfect square. How do I know it's a perfect square? Well, I've done all of my revision on this like you should have. So we can split that as a square, like so, plus 2 squared, where we need to make a cosmetic change because you can see that this is negative here. It's going to be plus, minus, and then minus. So you can see that we've got the perfect square situation. Next, because it's perfect square, we can instantly put it in its factorized form of a is x, b is minus 2, all squared. So that's our factorized form here. Finding the zeros, you can see that there's an x out the front here. If you put 0 in there, the whole thing becomes 0. And if you look inside the brackets here, if you put a 2 inside for x, then this cancels out to be 0 as well. What's more interesting is that notice that this is a power to 4. So what you're saying is that you've got a double 0 here, and this is also a double 0. So there's actually 4 zeros. So that's squared, so that means there's 2 zeros, and this is squared here, so that's 2. You can just leave it as blue if you want. You don't have to mention it's a double 0. Okay, final example, final special case example. We have 2x squared minus 4. We want to factorize this. Now again, you can see that there's a common factor of 2 in here, so let's just pull out the 2's. Next, what you can see is that we're dealing with, you might not see it perfectly, but you can see that we've got an x squared minus 2, so the linear term is missing. And what this flags is that we're dealing with a difference of 2 squares situation. Identifying that it's difference of 2 squares, what you can do is you can say x squared, take, and then you square root the 2 in here. In this case, we don't actually perform the calculation, we just say we're square rooting it, and then we raise it to a 2. So instantly you see that this is dots. From there, we can jump straight into the factorization, where we're dealing with x, take, root 2, x plus root 2. And there's your factorized form. Finding the zeros. First 0 is going to be the opposite of this term inside here, so if that's minus root 2, then it's plus root 2. And because this is dots, the opposite 0 is at the opposite one, so you can say plus and minus. So 0 is at plus or minus root 2. So in summary, what we had a look at in this lesson was, firstly, how we could factorize non-monic trinomials. And the first method we looked at was using the sum and product method, where the difference in this one is you have to get the product by multiplying the constant with the coefficient of the second order term. You then just use the same process of sum and product before to get to the factorized form. We also had a look at how we can make it such that the coefficient of the x's in the brackets is 1, so you just take out the factor in front. And then finally we looked at some special cases where we were dealing with powers that were above the second order, in which case we just factorize out that extra variable or extra x. We then looked at where we can encounter perfect squares, and we looked at where we encounter the dots situation. With these two over here, you can use the sum and product as well. It still works, but it's not as quick.